Jai Hind to all. My name is Divya Sharma and today's video lecture is on half wave dipole. So, far field due to sinusoidal current distribution, that is half wave dipole, or you can say quarter wave monopole antenna. So, in this half wave dipole, lambda by 2 antenna is called as half wave dipole, or you can say Hertz antenna. A dipole antenna is defined as symmetrical antenna in which two ends are at equal potentials relative to the midpoint. So, it may be defined as a straight radiator usually fed at the center and producing a maximum of radiation in the plane normal to the axis, because dipole antenna has maximum current at the center. So, this is the half wave dipole. Now here, this is your antenna, means this is your source. So, this is your antenna, and this is at the bottom side, this is the mirror image of this antenna. So, here you are considering some part of this antenna that is representing by dz. Now, height of this antenna up to this center, from axis to center, that is z, and height of this antenna is representing by h. And if you are considering the mirror image of this antenna, then total height is equal to 2h is equal to L. This is your dipole antenna. Now, angle between this axis, if you are considering a point P here, so distance from this point to this center of this dz, that is represented by capital R is equal to R minus Z cos theta. Now, if you are considering from the center to this point, that is represented by R. So, this is the point. So, here you have to find out the average power, and power is in terms of electric and magnetic field. And as you all know, electric field means E is equal to minus j omega A, E is equal to minus j omega A minus del V. So, already it was discussed in the previous lecture, and magnetic field is equal to what? Del cross A. So, you should know A here, V here. So, you can find out electric and magnetic field, and when you are finding the power, so you have to find out the average power. Why you are finding average power? Because you are considering this point at here, but you can consider, let it be this point is here. So, you can consider this point P is here. So, you have to, means some power, if you are considering this point, then some power is there. If you are considering this point P, so some power is there. So, you are considering here average power at this point P. So, you have to calculate average power. Now, aim of this article is to calculate and you have to find out radiation resistance also. So, for radiation resistance, as you all know, P is equal to I square R. RR is your radiation resistance. So, when you are finding radiation resistance, so you should know I and power. Power is your average power, right? So, you should know power, you should know I, then only you can find out average power. And here you should know A, you should know V, then only you can find out electric field, then you can find out magnetic field. Then only you can find out electric and magnetic field, means average power at this point P, or you can find out radiation resistance at this point P. So, from the previous lecture, there is a difference only that you are considering here mirror image of the upward antenna, right? So, it means what? It means you are considering here half wave dipole. So, now retarded vector potential. So, you have to find out A means AZ, because you are considering here Z axis. So, you have to find out AZ here. Now, first you should know I is equal to what? I am sine beta H minus Z. It means from this figure, if you are considering Z is greater than 0, then you have to consider here sine beta H minus Z. If you are considering from the figure Z is less than 0, so I is equal to I max sine beta H plus Z. Now here, IM is what? Maximum current at current loop, and beta is your phase shift, H is the height of the antenna. Now, let us consider a current element I, dz. So, P is a distant point far away from the antenna. So, you are considering here P point, right? So, here the vector potential at point P due to the current element I, dz. So, you have to write down here dAZ. dAZ is equal to what? Mu in bracket I dz e ki power minus j beta r upon 4 pi r. And r is what? R is the distance of point from current element I dz. Now, total vector potential at point P due to all current elements of an antenna. Now, how you can find out DAZ? So, you are considering here, this is the half wave dipole antenna. So, you have to consider this is your 0, right? And this is the height of this antenna, and in the below side, downside, you are considering the mirror image. So, this is H height and this is also H height. If you are considering the limits, so minus H to 0 and 0 to H. So, you can consider here limits minus H to 0, then 0 to Z. So, find out DAZ while putting these values. Now, here put the value of DAZ. So, DAZ A value you can put here, and you can put these limits, and you will get the result in form of here. This is your result AZ. While you are solving these equations, you should know for large values of R, the radiation lines at point P are parallel, and R is equal to, capital R is equal to minus small r minus Z cos theta, and capital R is equal to R at large distance. So, when you are putting the value of AZ here, and you are putting here limits minus H to 0 and 0 to H, and you will get this equation, means you will get the value of A is equal to what? Mu I e to the power minus j beta r upon 4 pi r. So, here put the value of I. I is equal to what? I m sin beta H minus H plus Z. When you are considering the limit minus H to 0. Now, here you are considering 0 to H. So, you have to write down the value I is equal to I m sin beta H minus Z e to the power minus j beta r dz. So, while you are putting these values capital R, so you will get this equation AZ is equal to this equation. So, you can solve this equation and you will get the result. Here, before getting the result, you should know for half wave dipole lambda by 2 antenna you have to consider, means L is equal to what? Lambda by 2 is equal to 2H, or H is equal to lambda by 4 is equal to pi by 2. And sin beta you can calculate sin beta in bracket H plus Z. It means you can put the value here. H is equal to what? Pi by 2. So, put here pi by 2 and you will get the result sin beta in bracket pi by 2 plus Z is equal to sin beta in bracket pi by 2 minus Z is equal to cos beta Z. It means in place of this sin beta H minus Z, you can put here cos beta Z. So, put here, and you can take common from these two brackets. You can take mu I m e to the power minus j beta r upon 4 pi r. In bracket, you have to take limits minus H to 0. Here you have to take limit 0 to H, and put here the value of sin beta H minus Z is equal to cos beta Z. Here also sin beta H plus Z is equal to cos beta Z. Here same, means sin beta H plus Z is equal to cos beta Z. Sin beta H minus Z is equal to cos beta Z, as we have calculated from this equation 5th. So, put the value here and you will get the result while you will solve this. So, here when you are solving, so here some terms are there, e to the power minus e to the power j beta Z cos theta, e to the power minus j beta Z cos theta. So, how you can write down this is in exponential form. So, you have to write down this exponential form in terms of cos and psi. So, how you can write down e to the power j beta Z cos theta is equal to what? Cos beta Z cos theta plus j sin beta j in sin in bracket b z cos theta, and e to the power minus j beta Z cos theta. So, you will get here negative sign. Now, terms are same, only the sign is changed. So, add these two equation in above this equation. So, you can put all these values and you will get the this equation. So, adding, when you are adding e to the power j b Z cos theta plus e to the power minus j beta cos theta, when you will put these equations, so you will get this result 2 cos beta Z cos theta. So, you can put this equation, you can put this equation here from this to this, right? So, you can directly write down here 2 cos beta Z cos theta. So, when you are integrating 0 to Z, so here 2 cos alpha cos beta is equal to what? Cos alpha minus beta cos alpha plus beta. So, you can put here the value 2 cos beta Z cos theta, means here you are getting a combination of 2 cos alpha cos beta. So, you can put here cos alpha minus beta plus cos alpha plus beta, right? So, put here this term, and while you are integrating, so cos term will integrate, when you will integrate, you will get result in form of sine. And here also, if you have cos term, so when you will integrate, you will get here sign, and you can put the value of, put the limit 0 to h. So you will get this equation while you will evaluate the integration sign. So here beta is equal to 2 pi lambda, 2 pi by lambda, and z is equal to lambda by 4, and beta z is equal to pi by 2. So here this is your phase shift, this is the length of the antenna, this is beta z pi by 2. So you have to consider these terms, and you can put here these terms in this equation, right? So you will get here, when you will put these values, you will get this equation in this form. So your equation is Az is equal to mu Im e ki power minus j beta r upon 4 pi r beta in bracket 1 minus cos theta cos pi by 2 cos theta plus 1 plus cos theta cos pi by 2 cos theta upon sin square theta. Now here, when you will get this equation, so you can solve it, and you will get, finally you will get this equation. Az is equal to what? Az is equal to mu Im e ki power minus j beta r upon 2 by beta r cos pi by 2 cos theta upon sin square theta. So this is the value of Az. Finally, when you will put all these values and integrate it, and after that you will get this result Az. Now here Az is for electric field, so you can find out easily electric field. Now here magnetic field intensity. So magnetic field intensity means H is equal to what? Del cross A, and del cross A, phi is equal to, means curl of the equation in spherical coordinates. So curl of the equation in spherical coordinates means del cross A phi is equal to 1 upon r del upon del r A cos theta minus del upon del theta AR. So the current element is placed along the z axis. So field at the distance point, it means AR is equal to 0 and A theta is equal to minus AR sin theta. So you should know the value of Az, then only you can put the value. So here del cross A phi is equal to what? 1 upon r del r minus r Az sin theta. When you will put here the value of A theta, you can put here this value A theta here, and you can integrate it, and you will get del cross A phi is equal to this. Now mu H phi is equal to del cross A phi. It means that is equal to 1 upon r in bracket del upon del r in bracket minus Az sin theta dot r. Now substitute the value of Az from equation 8 in equation 9. This is your 9 equation, and previous equation was 8. So you can put the value of equation 8 in equation 9. So here mu is equal to H phi is equal to 1 upon r in bracket del upon del r bracket start, next bracket start, minus mu Im e ki power minus j beta r cos pi by 2 cos theta upon 2 pi beta r sin square theta bracket close. Now after this bracket you have sin theta r. So when you will integrate it, means you can you have to differentiate it, and you can put all these values, and you will get this result. Now here, so your result is what? H phi is equal to Im upon 2 pi r in bracket cos pi by 2 cos theta upon sin theta. This is in units ampere per meter square. So this is your magnetic field. Now here you have to find out electric field also. So electric field, how you can find out? E theta is equal to eta H phi. So H phi already calculated here. So you can put this value and you can find out. So E theta is equal to what? Eta, you all know, eta is equal to, you can put the value E theta is equal to eta H phi. So you can put here E H phi. Now here, how you can calculate it? This is your eta 120 pi, and H phi is equal to what? Here I am 2 pi r. So I am 2 pi r in bracket. This means this term you can put here in place of H pi. So when you will put this value, eta is equal to 120 pi for free space. So here you can put the value eta, and here you can put the value of H phi. So H phi is equal to Im upon 2 pi r in bracket cos pi by 2 cos theta upon sin theta. So when you will put this value and solve it, then you will get equation E theta is equal to what? 60 Im upon r cos pi by 2 cos theta upon sin theta volt per meter. This is your E theta. Now expression for average power. So electric field is calculated and magnetic field is calculated. So power is what? Power is equal to E into H. So here you have to find out maximum power. So maximum power in terms of Poynting vector is just a product of peak values of E theta and H phi. So you can write down P max is equal to mode E theta mode H phi. So here you can put the value of E theta and H phi. Now average power is equal to what? Average power is equal to E theta upon under root 2 product means dot H phi upon under root 2, right? So here average power is equal to what? Finally it is half of E theta and H phi. So here you can put the value of E phi, E theta, and here put the value of H phi. So you will get here P average is equal to 1 upon 2 pi Im 2 pi r dot 60 Im upon r in bracket cos pi by 2 cos theta upon sin theta ka whole square. Now after resolving this equation you will get here P average is equal to 15 Im square upon pi r square in bracket cos pi by 2 cos theta upon sin theta ka whole square. Now in terms of RMS value, so you have to find out in term of RMS value. Here this is in term of I max. So how we can find out IRMS? P average is equal to what? 30 means you all know I max and IRMS. You can find out I max is equal to what? Here you can put the value 2 in IM is equal to what? 2 IRMS. So here multiply 15 by 2 IRMS square upon pi r square. This is your cos pi by 2 cos theta upon sin theta ka whole square. It means what? Im is equal to under root 2 IRMS. So if you know this Im is equal to under root 2 IMS, you can put here this value and you will get here 30 IRMS square upon pi square and this bracket. So this is your average power. Now total power radiated. Total power radiated, how we can find out total power radiated? Total power radiated is equal to integration P average dot ds. Now here put the value of P average. P average is what? P average is 30 IRMS square upon pi r square cos in bracket cos pi by 2 cos theta upon sin theta ka whole square. So put here this value P average in this integration sign and ds is what? ds is equal to 2 pi r square d theta and this ds. So you can put here ds is equal to what? 2 pi r square d theta. Now here this is closed integral 30 IRMS square upon pi square. This is cos square pi by 2 cos theta upon sin square theta. This is your ds. So put here ds is equal to what? This value. So 60 IRMS square integration 0 to pi cos square pi by 2 cos theta upon sin square theta. This is d theta. So 2 cos square theta, it means what? It means 1 plus cos 2 theta. So you can put here this value cos square theta means you can consider it 1 plus cos 2 theta. P total is equal to 60 IRMS square integration 0 to pi. So write down here in terms of cos 1 upon 2 1 plus cos theta cos pi cos theta upon sin theta into d theta. So here d theta, it means ds is equal to 2 pi r square d theta. So put here this value, then you will get your integration P total is in form of d theta. Now solve this equation. Integration 60 I RMS square into 1.219. So your in RMS radiated power is equal to what? 73.14 I RMS square. It means 73.14. This is your radiated power. Now you have to find out radiation resistance. So power is equal to what? Power is equal to I square into RR. If you want to find our RR, so RR is equal to power upon I square and I is your IRMS, right? So IRMS already find out. So put here the value of RR is equal to P upon IRMS and you know the value of power and you know the value of I. So you can put these values and you will get this equation 0 to pi 1 by 2 in bracket 1 plus cos pi cos theta upon sin theta into d theta. So you can put this value and you can find out that is RR is equal to what? 73 ohm. So this is your radiation resistance. So what you are finding here? You are finding radiation resistance, average power, and when you are finding average power, you should know electric field and magnetic field. Then only you can find out the average power. After finding the average power, you can find out radiation resistance. Now, thank you.